I know you're working in a production environment actively, so you know about some of this stuff as well. So I'm gonna lean on you as well. So, and of course, everybody's open, to provide, their answers, what have you. I know Lou has been doing tons of work on routing protocols. So, guys, feel free to jump in. So, right, let's look at our lab, right? So, routing, right? Its purpose, the main purpose for routing, just like spanning tree, it has a primary goal to move packets between different networks. Okay. So, we have R1, we have R2, right? And we have PC3. We have three networks that we're showing here. We got a 192.168.1.0/24 coming off the inside interface, the LAN on R1. That's what we're going to call it. That's going to be the inside interface, gigabit 0/0. Okay. And we have the WAN interface, that's what we're going to call it, going from R1 to R2 in a 10.10.10.0/30 network. Okay. And then we have a 172.16.1.0/24 network. Okay. And so, there's plenty of ways to where we can go ahead and force these routers to go ahead and on how they're going to route packets, right? Because, and I'm sure you guys saw my post, we saw what Claude fed in a couple of weeks ago as far as on the Slack channel is there's a difference between IP routing and IP route learning, okay? And so this is where the part of where I had to understand is where being an engineer comes in, because this is what you build. This is what hey, I want my routes to go a certain way. I want, use this protocol instead of this protocol, but I may want to have a backup protocol just in case this protocol doesn't work. This is where your engineering, all your CCNA, Network Plus, all your learning comes in. And so I really wanted to touch on routing again, start off because, again, we're about to go on a long 7-month plus journey on routing. So let's go ahead and start with the basics with route learning and what have you. So with route learning, we have, plenty of ways to go ahead and learn how to get from a source all the way to a destination or to a destination subnet. And so it's either using, a plethora of dynamic routing protocols or static routing protocols, okay? Which is the only one static routing protocol, but it's those are the ways to do it. And so you choose on how you're going to do it, but there's qualifiers on what gets installed into the RIB, the routing information base, or to keep it simple, the routing table, okay? So if you guys ever hear, right, whenever you guys get on the job or whenever you guys are in your lab, you see in your CCNP, because I'm sure most of the folks that are on here now, you guys see it either in your CCNA and your CCNP, the term a RIB and a FIB, right? Your routing information base is your routing table. This is where all your routes that you installed, that you created, that you wanted to get learned by different routers, what have you, to reach destination subnets. And so that is what you created, right? And for these, for the routes that you see in your RIB or your routing table, they had to go through a little election process, right? And the election process, again, similar to how paths are chosen within spanning tree, right? We have tiebreakers. So within the first tiebreaker, right, within getting a route installed into the routing table, it starts with prefix, right? That CIDR notation, that subnet mask. Okay, what's more specific? Okay, so for example, right, and we're gonna hop into the CLI and have some fun. We have this network, right? 192.168.1.0/24 is trying to reach 172.16.1.0/24, right? Let's say I'm using, a static route, right? 2 static routes to go ahead and reach it, right? And I go ahead and go to my senior network engineer. I go to Alex and I say, Alex, I'm going to go ahead and install, a route to go to 172.16.0.0/24, but I'm going to switch the CIDR notation to be I don't know, a /28, right? And I'm also going to install a route for it to be a /24. Claude, which route is going to be installed into the routing table or the rib? The /28 or the /24?
It's going to be that long prefix. It's going to be that 28. That's more specific.
So I hope that made sense, guys. So that cited notation is what makes it more specific. So, and you guys will see it in your CCNP book, and I'll make sure I take screenshots later. But that's the first tiebreaker. If a routing, right? If a routing information base or a routing table, you guys, us being engineers, we install 2 routes, or it learns 2 routes from a dynamic routing protocol from the same destination, but there's, you know, it's trying to look for the longest prefix, which is the most specific subnet mask for that same destination subnet. It's going to choose the one that has the longest match, like Claude said, which is more specific. So if I have a, again, 172.16.1.0/24 versus a /28, the routing table is going to choose a /28 because that's more specific. It has less numbers to go through within that subnet, rather than the /24 has to pile through 253 addresses. Does that make sense?
Yes, sir. It makes sense.
Cool. So let's go ahead and give it a shot. Let's go ahead and hop on in here. And Claude, while I'm doing this, if you can drop some knowledge, you know, drop your experience, or Alex, drop some experience that you guys have about longest prefix and how it makes sense to you.
I'm gonna go ahead and let Claude take over this question.
No, I got this. All good.
Well, I've seen experiences where, like he described, you know, you have this long routing table, and like, for example, with OSPF or something like that, and you know, you may have a /16 in there, and you may also have something a little bit more defined. You know, you may have a /27 or 25 or something like that. And I have seen situations where someone would go and they would try to erase one of the prefixes. And what happens, especially with OSPF, you know, you just can't delete a prefix. But I've actually seen a situation where, you know, you go to delete a prefix and, you know, you think, okay, now your routing is straight, and you go to send it. And what's happening is it's still fighting between the 2 prefixes themselves. So what happens in OSPF, you understand that you put things together as far as that dynamic routing, they're known as processes. And believe it or not, sometimes you can delete something, for example, a route or prefix, and you think it's gone. But because you didn't clear the process, there's still remnants of it in the table somewhere. And literally what happens is that router will fight with itself, trying to determine, where should I send this packet when it has these 2 addresses, these 2 prefixes that are very similar in nature, you know? So, and the thing is, you can do a quick glance and you can do a show IP route, and you'll see it, you'll think you'll have it, you'll think you'll be able to see it, but because they'll be so close, you know, your brain will just skip over it, you know, and it'll be something as small as it fighting over another prefix that's very close, you know, and it's having a hard time trying to determine which one do you really want, you know. Now, some of you do know You know, sometimes that summarization can come in handy. You know, uh, situation where, you know, you have, let's say 3 networks, and instead of advertising 3 separate networks, you know, summarization, you know, you advertise one network that actually represents all 3 of them together. Okay, and you can send that across the wire, and you know, the router on the other side can determine, okay, I got this here summarized in, you know, this here in this big /22 or big /23 prefix, but I know specifically that this packet needs to go down this avenue or path. You know, so there are times when the summarization where the larger prefixes come in handy, and then there's times where it can actually hurt you. You just got to know the application on when to actually utilize it. And you know, you can see all kinds of squirrely things with routing. I keep saying that I'm gonna do this video on Netflow, but you know, a lot of times you can, you know, everybody's here is familiar with pings. Everybody's here familiar with trace routing, and you know, tracing a packet, you know, at that layer 3 as far as the path that it takes. You know, trace route will do that. You know, trace route sends out a single ping. You know, each time it's almost like a pulse, but it sends out a single ping to each hop, and it records, okay, it stopped here, okay, it stopped there, and it keeps doing this until it reaches that destination. You know, that's one way of tracking that route. Another way of tracking that route is, like I said, using Netflow, where you can actually set up monitors on interfaces that will determine, just like Dave was talking about when we were doing layer 2 stuff, source and destinations. Netflow will literally record a source IP address if it's just passing through to get to somewhere else, just say get to another network. It will literally record a source address, right, and a destination address of where it's going to, and you know, it'll actually keep a cache of that. And like I said, this is what Netflow allows you to do, is actually see what kind of streams network traffic is coming through a given interface. Now, in an enterprise environment, you got, you know, SolarWinds, you got applications out there called like Live Action, and any other type of, they got a whole bunch of different types of third-party programs that actually catch that stuff. But you can also catch it, especially in a lab environment. It's good to catch it in a lab environment where, you know, you send in one ping from, let's say, and I'm just generically speaking, from the bottom half of your topology up to maybe a loop back at the top half of your topology. But you want to see how it actually travels. And Netflow will pretty much raise the flag when that given packet comes through its monitored interface. You know, you can see if you have some asymmetrical routing going on. You know, if you have symmetrical routing going on, because let's say, for example, you want traffic to only flow one way, going in one direction, and you want it to come back in that same direction. Well, what if it's not doing that? You know, Netflow can pretty much track and tell you, okay, your stuff went this way, but it came back that way. You know, and if that's what you want, that's totally fine. But if it's not, you know, then that's when you start getting a little bit deeper of, you know, the traffic engineering. At the basic level, you know, you guys understand administrative distances for the various protocols. And even within those protocols, like for example, let's take something simple like RIP, okay? RIP, I believe, if I remember correctly, it's been a while, but if I remember correctly, RIP is based on hop count, okay?
Mm-hmm.
So
Yep.
you can actually manipulate your metrics to have traffic go one way or the other based on making it think that there's a given amount of hops to get to XYZ, you know. Uh, Same thing can be done. You can manipulate OSPF. You can manipulate those metrics based on the cost, okay? So you can manipulate the cost in a dynamic protocol such as OSPF and force traffic to go one way or the other, okay? And we're not even gonna get into BGP. Oh my gosh, BGP has so many different methods of
Oh no.
manipulating traffic. You'll spend a lifetime just understanding just a couple of those methods, but routing is where a lot of you guys are going to make your bread and butter, understanding routing. That's where a lot of y'all guys are going to make y'all bread and butter. Stuff within a LAN, it's okay, it's cool, but most of your biggest problems is when it leaves a facility. What the hell happened to it when it left the facility? That's where your understanding of routing has to really be honed. You start working in these data center environments and you sending traffic across the globe to the other side of the world. Yeah, you got to understand routing to understand where is actually going. You get traffic that's getting black holed somewhere. You got to understand where it's getting black holed at. Where is it just getting lost at? You start talking about route distributing. You want your interior gateway protocol networks to be advertised to your exterior gateway protocol so it can get out. So you may have resources within your interior gateway protocol that may need to hit resources out there in the World Wide Web somewhere, or either in another autonomous system out in that World Wide Web somewhere. So understanding how to redistribute interior networks to the outside world, at the same time, and in a lab environment, you can play with this, but at the same time, we all know that we don't want to distribute the World Wide Web's routes into our lands because it's just too massive of a database for our IGPs to try to handle and manipulate, and don't get me wrong, some of today's routers that you see out here, they can handle some pretty good stuff. But, when you start thinking of exterior gateway, BGP, you talking about hundreds of thousands of routes, if not more. And, if that all of a sudden floods your interior gateway protocol, you might have some performance issues coming up real fast, and that gets you into the game of filtering, what if you want to take route A, route B, and route C and send them to a destination, but for some reason you don't want route C to go to that destination. You want to hold off on that particular route. So you got to, there's a point where you start learning how to filter within the routing domains and within the routing protocols. Let me see where else. I know some of you may have seen the video I did actually last year I got another one I got to do, which is actually a continuation on that, where I was talking about communities. Communities is another way of filtering. You know, you're wanting specific prefixes to do specific things. Okay. That's something that, you know, you guys, when you get into these production environments, you will see that a lot. You will see filtering, you know, and there's multiple ways to filter, you know, because we're talking about, you know, we had a conversation the other day on one of those impromptu sessions where we were talking about ACLs. You know, ACLs is a way to filter. That's a simple way to filter when you think about it. But
Mhm.
there's also other more complex ways to filter as well. And you know, once you start going down this routing rabbit hole, you'll get a taste of them for sure.
Most def. Most def. Claude, thank you, man. Thank you. Let's go ahead and hop in this lab. And let's see, you know, what happens, and of course the process and what have you, about routes getting installed into a table, and understanding how, you know, how a router goes ahead and chooses the right route to go ahead and pass traffic to a destination subnet. So I went ahead when Claude was sharing his knowledge about routing, what have you. And again, this is all recorded, so you guys be able to go back and take a listen. I know I typically do whenever someone that's a senior in the field has, you know, definitely has a lot of experience or what have you in a production environment. So definitely take a look at that whenever you get a chance. But again, we have our two networks, and as you guys can see, I added a few things to the, you know, to the table as far as another. I added another interface to the router. Of course, have some redundancy there on how to get to the different networks. And we're going to go ahead again and take a look and see how, you know, things get installed, what path it takes. We're going to take a look at Wireshark just to see, you know, what path our traffic is taken from its source, being the 192.168.1.0 network, to the destination, and vice versa, where the 172.16.1.0 is the actual source. So we're going to pick up on some ingress traffic and check out some egress traffic on both R1 and R2, okay? So what I did, right, I went ahead, let's go ahead and dissect this routing information base. And I'm going to keep saying that word because I know we know what a routing table is, but I'm going to keep throwing that word out there because I want you guys to really drill in your head, okay, a routing information base is simply a routing table that has routes in it. That's it, right? So let's go ahead and take a look at it, right? So go ahead and look at R1, okay? Since our first source is going to be PC3, we give it a, right here, it shows us 192.168.1.1, okay? So router 1 is going to tell any packet that's coming from PC3 if it wants to reach, you know, that 172.16.1.0 network, where to go, how to get there, okay? And so I went ahead and installed two static routes, right? And that AD for static routes has an AD of 1, okay? But in the tiebreaker process, right, whenever routes get installed, the router is not first looking at the AD. It's looking at, like Claude was saying, that prefix match, right? The longest prefix match. Who is more specific, right? And that's what we're going to look at today, whenever we're trying to trace this packet. So we have both of the routes got installed. We have a /24 and a /28 for the, you know, for the 172.16.1.0 network, which is our destination for our first test, okay? And so we're going to go ahead, right? We see that the router actually installed both. Oh, looks like somebody joined in. The router installed both static routes that I went ahead and installed in. And so it actually didn't complete the test that I was actually trying to show you guys, but we'll do it in a little bit with dynamic routing protocols, and we're going to erase this. But still, we're going to go ahead and see what's going to happen as far as, you know, choosing which route to use, okay? So with looking at this, right, again, we go back to what Claude's answer was. If it had to choose, if router 1 had to choose between, you know, /24 and a /28, it's going to choose the /28, right? And it should be using, again, that second link, gigabit 0/0/2. So let's go ahead and trace that. So I'm going to go ahead, start a packet capture on my ingress interface coming from my source, is PC3. And I'm going to track that traffic coming from that source that's on that network, okay? I'm going to let that keep going or what have you. We're going to go ahead and take a look at it and dissect it as network engineers, which all I expect to see in that packet capture is, hey, we have traffic coming ingress into the router for the flow of traffic, okay? So now what I'm going to do, right, is I'm going to go ahead and do a packet capture on both egress interfaces, right, going towards my destination network. And again, I have two ways to get there. If we look back at our routing table, we have two ways to reach there: over the 10.10.10.0/30 network and the 10.10.20/0, 10.10.20.0/30 network, okay? So we're gonna do a packet capture on both so we can, you know, see our tests once we go ahead and initiate our pings. We're gonna do a packet capture on gigabit interface 0/1. Put that there. Okay, we have that rolling. Let's go ahead and do the second interface, okay? We have some traffic. Again, this is the ingress interface. It's the gigabit 0/0 on router 1. This is gigabit 0/1 on router 1. This is gigabit 1/2. I'm sorry, this is gigabit 0/2 on router 1, okay? So now let's go ahead and initiate some pings. Start some traffic. Pull that up, and we're gonna go ahead and ping 172.16.1.1, okay? Let's go ahead and add it. Whoops. 16.1.1. So, Lou, before I press any of the egress interfaces, which interface do you expect the traffic to be leaving the router?
Say that
And
one
why?
more time. State that one more time.
Sure. So with me starting the ping and with everything that was shared as far as the routing information base, what path do you expect to see the pings travel over? Which interface should you see the traffic flow over? Gigabit interface 0/1 or gigabit interface 0/2? And explain why.
Prefixes are the same.
Hmm?
Let's see.
No. I'll pull up the routing table as well. And again, if you want to dissect it with everybody else on the call, please, we can. Let's go ahead and talk theory.
So the ping's coming from PC1 or PC4? I kind of missed that part.
PC3. Yeah,
Oh, PC3.
PC3.
Okay. Okay, I'm sorry. Yeah, PC3.
Mhm.
So
Yeah, and it's pinging.
so traffic's gonna go through router, you know, the gateway, which is router 1. So
Mhm.
it should be. Oh, okay. And then there's two different routes. Okay, so
Mhm.
let's see
I'm
which one
still
is.
checking here. I'm still checking here.
So if they're directly connected, right?
Right.
And you said you have the routing table up. Okay, so then you got static routes going.
Mhm.
Oh, okay. Well,
I'm going to take a wild crack and say, based on what I'm looking at in the routing table, let me see here. I'm going to have to say gig /2. Go that route. If I'm wrong, by all means, someone correct me. The reason I specified gig /2, just because I see that the 10.20 seems to be connected, and to that particular interface, and that one has the longest prefix. Again, if I'm wrong or if I'm off, somebody let me know.
So let's dissect your answer, right? So you said because it's connected. What do you mean by that?
Yeah, I might have not said that correctly. So when I'm looking at the routing table, I'm looking at the connected route of 10.10.20.0. So I see it's directly connected to gig 02. And then looking at the static route, the one that's highlighted, the /20 with the longer prefix. This correctly.
Which prefix are you looking at?
I was looking at
The /30 or the /32?
I was looking at the /30.
Okay. So you're looking at the /30, and what else helped you make that decision as to why gigabit 0/2?
Simply because well, not simply, but I just see the prefix the longest prefix is tied to the, okay, my screen just went off. Hello?
No, I'm still here.
Oh, okay, no, I was looking at the screen and it just vanished.
Yeah,
Oh yeah, I stopped sharing. Yeah, I stopped sharing.
So I said that the prefix 28, just looking at that because I see the gig 0, the interface, the gig /02 is associated or can, to that particular IP address, the 172 with the 28 prefix. I mean, I'm not sure. I'm trying to figure out how to actually put it in words correctly.
I think you're on the right track. I mean, I'm going to go with the
100%.
/28 also, because that is the largest prefix. I think the confusing part is that there's two interfaces directly connected, but you're on the right track. /28.
Right, and looking at the exit interface, the /0/2, it's just like it seems to be associated with that particular IP or that path. So they're both great paths. It's just that one has a higher prefix, which is better, and the gig /2 seems to be lined up with that particular IP with the longest prefix. Again, I'm not sure if I'm putting it in the correct words, but I'm just trying.
No. It's all good. Claude, let's dissect this. Let's dissect Lou's answer, because I love where he's going with this. So, Claude, what do you think?
All right, so you got two different choices, right? You got a /24 and a /28. So think about it like this. Lou, if I tell you to give me a phone call and I give you this number, I give you the number 555-1234. Is that a legit number?
No, it's when you say legit, I mean it has to have an area code, a
Okay.
country code, and you know.
Okay. So if I give you now, depending on where you are, 555-1234 or whatever that those 7 digits might actually work. And at
Right.
one time, it actually did work. Then what happens is things go on, things progress. Now we got to start dialing the area code. So if I give you the number 212-555-1234, which one's a little bit more specific to get to me? That
Yeah,
second one or
yep,
that first one I gave you?
No, the second, the last one you
Yeah.
just gave.
So that's the idea that Dave's trying to get across in this here example here.
That it's more of a specific path.
Yeah, yeah.
There we go.
Is this safe to say, and I'm just going to throw this out there, is it safe to say it's similar to, not similar, but in a way, kind of like an analogy where it's kind of like a hosted static route, like it's a specific, you know, again, I'm not sure if that is relevant, but just trying to,
Yeah, static routes are specific. Yeah, I agree with you there. They are specific. And static routes, unlike this situation here, where the router can make a choice because it's redundant links. And
Right.
as you know, if it's a static route, it's only one way or the highway, But to the point of it being specific, like a static route, yeah, I'll agree with you there. Static routes are specific. And in the scenario of where I use the telephone number without the area code and the telephone number with the area code, that one's more specific will probably get you to its destination a lot better.
Right. I see.
So, Claude, thank you, Lou. Good answer. Honestly, you, and I think that's where Alex and Claude was trying to get to. Your answer was perfect. It was good. That's exactly was it, right? The router went ahead and made the decision and said, I'm going to go with the most specific and forward my traffic that way. Okay. And so with our destination, right, being 172.16.1.1, right, without us even looking at the MAC address and seeing which interface it's using, right, me making you guys aware, we're doing the packet capture, this is signifies, interface 0/1, and this signifies 0/2, right? Lou, me and you are troubleshooting, troubleshooting this and seeing, okay, what path is my traffic taking egress from the source, right? We can see what from these two packet captures. Which link is this using? Is the router one using to traverse this traffic from the source to the destination network being 172.16.1.1, 1.0, I'm sorry. I want you to take your time in answering this and taking a look at this packet capture.
Say
You need to go to
just say the last part of that question. What is the egress?
Yep. What is the egress port from router one that router one is taking to send that traffic from the source to the destination? Source being 192.168.1.1. And guys, just as a quick note, again, I'm going to use these big terms because, again, you're going to be asked this on interviews and on exam, et cetera, et cetera. What you thinking, Lou?
I'm looking at this packet capture.
Mhm.
Trying to.
Let me know if you need me to stop it.
Yeah,
So,
don't let it distract you.
all right. So, okay, the egress port from R1 going to R2. Which one is it choosing? Is that what you're asking me? Oh, I just want to make
Yep.
sure I understood you.
Yep. What port is it choosing? What egress port is it choosing? Because it has two egress ports
So I
to
would.
send traffic from 192.168.1.0/24 to 172.16.1.0/24.
I would say the gig/2.
Ooh,
Can you stop that right
you're
there?
correct. You want me to stop it? Perfect.
Yeah.
There you go.
So yeah, I would have to say that the gig2.
So it's using gig 2, right?
Gig2, yeah, the bottom one.
Okay. So now, with that being said, let's pull together what your answer was earlier and what you see through this Wireshark. You know, what you did with your Wireshark analysis. So again, from the source to the destination, right? From 192.168.1.1 to the destination 172.16.1.1, we can formulate what type of analysis from this?
Sorry, just relay that one more time, please.
Sure. So from our Wireshark capture, right? What analysis can we provide to, let's say, another engineer that wants to confirm the path of this traffic? What would you muster up and say? What's the path of this traffic that it takes?
Well, I mean, apart from the fact that it's taking the specific or the more specific path, I'm not too familiar. I mean, I've worked with Wireshark once. I mean, not often, but I still have a lot to learn with Wireshark. But I mean, on the tabs, like if I had to relate or to confirm with another engineer, like on the tabs, like the one that's on the little triangle tabs, I know that there is. I think it's the one that's the layer 3 or the IPv4 that you can you drop it. It should be able to show you or confirm. Right.
There you go.
Okay, we are right down the bottom. Yeah, source and the destination.
Mm-hmm. Come on, Lou. I know you can do it. Because it was just in your answer. I want you to formulate your analysis from this. What can you confirm? And I don't care if you don't have experience in Wireshark. What can you confirm from this data?
So looking at the data in the Wireshark, I mean, you definitely confirm that we see the source IP of 192.168.1.1. We see that that is the source IP, and it did go to its destination 172.16.1.1. I mean, Wireshark does confirm that, and it does show the destination. So I mean, I'm missing something there.
Nope. Stop. We're not going to use the word we're missing something. So we're going to formulate it all together. So you confirm the first part, right? The second part, what did I explain first? this capture is taking on what interface? Gigabit what? 0 / what? 1 or 2?
0/2.
There we go. Now, finish your analysis. What port is it taking to send this traffic from the source to the destination? From looking at the Wireshark capture and your routing table.
Do this, Dave. At the same time that you have port 1 running, show the data in there.
That's, hold on. Yeah. Nah, hold on. That might confuse. Hold on.
Because what I was thinking is that it would be less captures in that one.
Which one?
So the tab you got highlighted is capture _1_2. That's the one we're looking at.
Yeah.
Yeah. What does that one look like?
Oh yeah, we're gonna get to that.
Okay.
I want to stay
okay.
on this one. Yeah, I want
Okay.
to stay on this one. So Lou, second piece. Again, you're in the hot seat because again, you're engineer now. So I want you to be used to it. So with that, let's go ahead and formulate our analysis. You took care of the first part. What's that last piece? What can we confirm? What port is our traffic from our source, right? Our source being this network going to this network. What can we confirm from this? And it has to do with the ports. Which port does it leave to reach 172.16.1.0?
It's going to leave, well, at the end, it's going to leave the gig 00 from router 2.
Nope, we're still on router 1. That's what I'm asking you about.
Okay, so it's going to leave gig 02.
Okay. Because of what?
Because of the prefix.
That's
Specific prefix.
That's it. That's it. That's your analysis. That's it. Does that make sense, everybody? Does that make sense on how to provide analysis as an engineer?
I guess I was looking for something more, I guess.
Nope. And it's, Lou, you did good. You did good, by the way. You know, you did good. But this is something you guys have to get used to, right? You know, I know we always talk about the why, of course, and layer 2. You guys see me talk about it a lot, and you hear Claude and you know, Alex and a couple of the fellas talk about it, and a couple of the women talk about it a lot within our sessions. This is where everything comes together, and you have to give your analysis, and all the theories that you've learned from your CCNA, your CCNP, all comes in. It's taking this route because of this, because in my evidence here is because of this Wireshark capture. I confirmed layer 2 and layer 3, and looking at my routing table, this supports my analysis. Okay.
Yep.
So we're gonna have more exercises like this, right? And dissecting IP routing and IP route learning before we even jump on OSPF and egrep, because Claude could just have a field day with that. I mean, I'm scared of. I got to tell you, I'm scared whenever we start talking about egrep and OSPF. I'm probably gonna have to get a wholesale version of Cafe Bustelo. I mean, it's gonna be ridiculous.
Oh,
but it's gonna be good learning.
Whatever.
But Lou, that was good. That was good. That's how you bring it all together. Okay.
Got it.
Right. So again, folks, my goal was to get you guys out of here at 9, but I know we went a little bit over. But again, you know, our goal is to, again, you guys get that knowledge. Did all this make sense tonight?
Absolutely.
Of what we touched on and how Lou you know, and again, I want to give a shout out to Lou of how Lou broke all this down. How we work together as an engineer to break all this down as far as what path, right? My traffic is egressing my switch and what path it's taking to pass this traffic. Did that all make sense?
Absolutely.
Okay. Okay. And again, guys, we're talking about tiebreakers within with IP route learning, what have you, and IP route forwarding, what have you. So we're talking about first prefix match, longest prefix match. Next, we're going to go ahead and the next session we're probably going to touch on, you know, going to that next tiebreaker, and we're going to go ahead and start implementing dynamic routing protocols and see what actually gets installed in the RIB, even though we programmed something else. Okay, so that's going to be on, you know, prefix, longest prefix match, but also AD as well. So we're going to have fun. We're going to have fun, guys. Dope session. Again, this is recorded, so I'm going to go ahead and upload this roughly right after this. Thanks again for joining. So we'll see you guys in 2 weeks, man.
Hey, keep
All right,
that
you
lab
got
up.
it, man.
Keep that lab up. You can look at something.
Keep
Yeah,
that
good
lab up.
Good
Yeah.
stuff.
I got you. We'll do.
I think we're gonna go into layer 2, the Ethernet MAC address.
Say it again.
During the analysis, I was looking at layer 2. Yeah, I was looking at layer 2. Can you hear me?
Yeah, we can
Yeah, I
hear
can
you.
hear you. Let me go ahead and let's go back to the lab.
Yeah,
Why were you looking at layer
I
two?
thought you were gonna go into layer 2 because you can
Okay.
see the direct source and destination, right? Because the way layer 2 works, the source and destination MAC changes when that frame's flowing through the network. The IPs
Okay.
stay the same.
So okay.
Okay.
So you could have
Hold on. Ooh, go ahead, Claude.
so you
Let's
could have
have fun.
verified the max of the interfaces to confirm whether or not. So is that where you getting at?
Yeah, that's where I was going.
Okay.
But
Okay.
but also David wasn't showing a lot of info, but that's where my mind is going.
Okay. Okay. Because the interfaces do have their own MAC addresses.
Right.
So Alex, let's do this. Let's do this. Let's go ahead and do it. So which interface do you want to look at first to confirm this?
Oh, okay. So you're talking about egress, right? So G02.
Yeah.
But where are you capturing the packets from on this? Yeah, where is that captured from? As far as what?
Both interfaces.
Both
On router
interfaces.
one. Yep.
Okay. Oh, so G00 and G02?
G0.
Yeah, so we
I'm
can look
sorry.
at,
All the
we can look
interfaces.
at-
All the interfaces on R1. So I'm capturing it on G0/0, which is this capture. I'm capturing it on gigabit 0/1, which is this this interface, this capture, and gigabit 0/2, which is this capture.
Yeah, let's look at the MAC source and destination on G02.
Okay, let's go ahead and do it. All right, here's your source.
Yeah, so let's see, source 50.01.00.01.00.02, and then destination 50.01.00.02. So that's where I guess that's where I'm confused. So from source to destination, because they look like the same MAC
Why?
address.
But it's not. Look at that third octet. I'm sorry, look at that fourth octet. Your source is a 01
On which
and that fourth octet.
oh, where?
So it's a 01
Oh, I
right,
see.
on your source. And
Yeah.
you have
an
an 02 in that
Yeah,
fourth
there
octet.
it is.
Mhm.
Yep. So 02 should be
Okay.
On router 2 G02 based on the
we
based
don't
on the
know.
prefix, right?
We
Right,
no,
we don't know
no,
that.
We don't know. And it has nothing to do with the prefix, right? Because a MAC address is individual to an interface,
Right.
right? It's unique to an interface. So let's verify. We're engineers. So let's go ahead and we're going to go ahead and ride on Lou's answer, right? It was gigabit 0/2. So let's verify and check that interface. let's go ahead and make it more specific. Include, and let's do address.
Five 001, 001, 002.
Okay. Look familiar?
Yep.
Okay. So, right before we go ahead and before we go ahead and move forward, how can we go ahead and check to check our destination on this router? Is there a way to do that, or our destination MAC address on this router, or do we have to go to the next router?
So you're talking about going, so from R1 going to R2, you want to see what the packet looks like on router 2?
Nope. I just want to see the destination MAC address on this router. Can we find that on this router, or do we have to go to the next router?
I mean, you can show MAC address table
On a router?
Or are you trying to mention? Right. No, that would be on a switch.
There's a MAC address table. Oh, there we go. Okay, cool. So is there any table we can look at on a router for layer 3 to confirm that this, and I said layer 3 has a trick, as just to throw you guys for a loop. What table can we look at on a router?
You're talking about the ARP table?
Absolutely. Right, because the ARP table has the IP address to MAC address mapping.
Right. Yes.
Okay, so let's go ahead and take a look at that. Okay. Do we see our MAC address on this table from our destination in a packet capture?
Oh yeah.
And you got a port to confirm. see how that ties in.
That could have been I think that would have been a really great answer as well. To my analysis. I'm not going to forget 100%. That one.
100%.
I'm gonna have to remember that one.
Alex, that makes sense.
I'd say they're equally both great answers, because you cannot know routing. And if let's say your interviewer is asking you about routing, and you go to this analysis, he'll say, no, I want you to talk about routing. So they're both important, I'd say, equally important.
Absolutely.
This answer just kind of like solidifies or reinforces your analysis on why you chose, or as an engineer, why we chose that path, or as the answer, or why we specified that answer. So this just solidifies much more.
Being able to verify it. Yeah.
Yep.
Absolutely. Okay. And this is where, right? There's another table we can look at to verify this as well.
Keep going.
On what path it takes.
Oh, the
destination is 172.16.1.0 or.
I mean, this is kind of like, let me do a plot analysis, right? This is like when you have your math problem, right?
Yeah.
1 + 2 is 3. Well, what's 3 - 2? 1.
Yep. So let's break this down, right? I know I was going to let you guys go at 9, but shit, Alex done started something. So, right? It's our routing table, right? Our routing information base. I'm going to keep saying that word because I want you guys to drill it inside of your head. Our routing information base. Okay. It has all of our routes that we installed, or were installed by dynamic routing protocols in there, right? It tells the router, how to get to a destination, right? From a source, what have you, right? It's going to be in there. But within our entire router, there's not just a routing information base. There's 2 more tables. You have your forwarding information base, and you have your adjacency information base, okay? And they all work together, okay? So go ahead and go step by step, right? And what I loved about Lou's explanation is Lou broke it down along with Alex's how the path gets from the source to the destination. This is your routing information base. This is your phone book for the router. This is how it knows how to get to that destination, right? But the router isn't built just from the routing information base alone, right? It uses other protocols, uses CPU, what have you, but it also needs to rely on, okay, what port do I need to forward it to? How do I know what port to forward it out of, right? We're gonna need a way to do that, right? And that's where the forwarding information base comes in, okay? And what that is, right? And I'll send you guys a graphic. I'm sure you guys seen it on my last LinkedIn post, but I'm sure you guys saw the graphic, right? The forwarding information base is made up of information from the adjacency information base and the routing information base, right? It's basically the cop that's in the middle of the street saying, hey, okay, go this way to get to XYZ, go this way to get to XYZ, right? But, right, on top of that, we also have our adjacency information base, and it pulls that information within the router from that protocol being ARP, right? It gets all the information of IP to MAC address mapping, right? And if the FIB, right, the forwarding information base is just a mirror, right? A mirror of the routing information base. It also needs a way to know, okay, how do I forward it as well? Using layer 2, back to what Alex was saying. I need to know layer 2. I need to know how to get there. We're gonna rely on that adjacency information base to forward it, okay? And so let's look at the Ceph table, right? For the forwarding information base. Let's look at that destination subnet again. Okay, so again, a mirror of the routing information base, but again, this is where that longest prefix match comes in. It knows where to send that packet. It's right here. Gigabit 0/2. Okay. Then the forwarding information base needs to know, okay, at layer 2, we're gonna go ahead and we have to make sure we know how to encapsulate it, right? Lou, what you did in your explanation, and I'm not sure if everybody heard it, Lou verbally explained recursive routing lookup. Here's what I mean by that. So we have our destination, 172.16.1.0. Our static route says it needs to go via 10.10.20.2. How does the router know how to get to 10.10.20.2? Well, it needs to do another lookup on how to get to 10.10.20.2. So it needs to do another lookup in the routing table. How do I get to 10.10.20.2?
And understand that part, folks. When you hear the term recursive, you're talking about a secondary lookup. That's what that fancy word is. You're thinking about a secondary lookup.
Okay.
Right. It's just going to specify the IP address of the next hop, pretty much.
Exactly. And Lou, I know you didn't know what you were doing, but you did. That's why you get 5 stars. He explained recursive routing to a T verbally. I'm sorry, I would have gave Lou the job. Off bat. I didn't even care if he knew the definition of the word. He explained recursive routing. And that's typically what happens, right? It knows, a router would know in its routing information base, it knows, whatever we program in or what we learned, right, from the dynamic routing protocols on how to get to, what's the next hop for a destination subnet. But now we need to go ahead and look up and see, okay, what's that next hop? Do we know how to get to that next hop, right? And so we have that in our routing information base, okay? And we have it in our forwarding information base. And it's more specific in our forwarding information base. The decision is made, it knows how to get there. Again, it's using in the forwarding information base, it already made its decision, hey, longest prefix match, we're there. Now, how do I know, right, to get to 10.10.20.2, off of gigabit 0/2. So I right here at the forwarding information base, I have my source layer 2 address, how to encapsulate that. But how do I know my destination layer 2 address? I'm going to look at the adjacency information base, which is we pull that from the ARC table. So then my destination is going to be marked there. .0.0002.0002. That's my destination. Now, with all of these, routing information base, forwarding information base, and my adjacency information base, right? Routing table, forwarding table, and my adjacency table, I now know how to encapsulate my packet, right, at layer 2 and send it off. Because just like Alex said, layer 3 never changes. Of course, there's specific cases, you know, as far as packet rewriting, but layer 3 never changes throughout the path of the packet. With each layer 3 boundary, it's going to go ahead and be rewritten at layer 2. Does this make sense?
Absolutely.
Rabbit hole can get deeper as time goes on.
Oh yeah, but we're not going to do that. I know it's Wednesday. You know, I want you guys to enjoy, you know, the night or what have you. But again, we're going to come back to this in 2 weeks, and we're going to go on. We're going to touch on dynamic routing protocols and how that applies there, okay? And how those routes get installed and choose the best route, et cetera, et cetera. Okay.
But hey, real quick, go back to that real quick.
I got you.
So scroll down that second half so we can actually see the IPs and the captures. Yeah, scroll that down, pull that down a little bit.
Gotcha.
Okay, so you see how on that port we got source 192.168.1.1, destination 172.16. Yep. Now go over to capture _1_1. You can see it reversed.
I was waiting for somebody to point this out.
See, that would have been another confirmation that, okay, port number 2 is the path that is taken to get there. Port number 1 is the path it's taken to get back.
Oh, okay. Okay.
That makes
So
sense?
that would have been another confirmation that port number 2 is the one being utilized. If you put those two packet captures side by side.
So one is actually transmitting and the other is receiving, sort of an analogy type. Okay.
100%. And again, all I did was, again, on the routing table of R2, is made the longest prefix, of course, a /28 for this network set to gigabit 0/1. So from the source to the destination, right, those ping requests get sent over gigabit 0/2, but those ping replies, right, the routing table says, oh, I'm going to go with whoever installed this, you know, this routing in here, right? I'm going to go over 0/1 because 0/1 has the most specific route, okay, as the longest prefix match. So I'm going to go this way. So that's why that source, 172.16.1.1, it traverses over gigabit 0/1 from R2. So those ping replies go back another way.
Okay, I see. So when you're doing the ping request, is going through the gig 2, the replies are going to come back traversed on gig 1.
Absolutely. Take a look at R2 to confirm it. We're going to look at all 3 tables again. We got our two routes, two static routes that I installed, right?
Yep.
Go ahead and look at the topology so it can all make sense. Okay. We have both of those installed, but the /28 is the more specific route. Okay, that is the most specific prefix match. Okay, and it's telling us it's going to 10.10.10.1, right? And again, we're not looking at the topology, right? I'm going to clear this out the way. It goes over 10.10.10.1, right? And just like Lou said verbally, right? We're going to do a recursive lookup because we need to know how to get to 10.10.10.10, right? In our mind, since we know, okay, it needs to go through the longest prefix match. We need to go ahead and do another lookup. How do we get there? /1. Okay. In our forwarding information base, which is just, again, a mirror of the routing information base or the routing table, tells us how to get there as well. This shows us the final decision from the routing information base of, hey, you're going to take this path. That's Lou's confirmation. As Lou being the network engineer, okay, yeah, longest prefix match. Even though we have both routes installed in the routing table, hey, this is the path it's taken to get there. Okay. Also confirms it right here. Okay. What's going to be the source, right? The source MAC address whenever the route is getting ready to go ahead and ship that packet out, right? We're going to go ahead and use our analytical skills here. Okay. Next hop is 10.10.10.1 is going over gigabit 0/1. So let's look for an interface that's using 0/1, right? Okay. So if we know our destination, our next hop is this, which is where we're sending it to, right? And we know what interface it's leaving. Okay. We looked at our packet capture to confirm, right? That's our layer 2 address, source address. It's a layer 2 destination address. That makes sense?
Yep.
Guys, good stuff. Good stuff. Any questions? I know this is a lot. Okay, I'll take that as a no. Lou, good stuff. Good stuff. Way to fight through. And again, guys, remember, none of us will always have the answer. Sometimes we need to just go ahead and take a step back and breathe and think it through. That's why we're all engineers. Okay? You know, never feel embarrassed, never feel too pride to, hey, let me take a look at that again. Let me take a step back and process this real quick. Perfectly fine. Perfectly fine. Okay? Well, folks, on that note, I'll go ahead and let you guys go. I already stole 34 minutes of your time. I will see you guys in 2 weeks. And again, we're going to still stay on this topic of, you know, tiebreakers and what routes get installed into a, you know, routing table or routing information base. I'm going to keep throwing it in your head because, again, routing information base is just the routing table. But I want you guys to know that first term that I'm shooting out to you. Okay?
Absolutely.
I'll see you guys in 2 weeks.
You got it. Thanks, Dave.
All right, man.
Later,
Take
boss.
care now.
Later, Claude.
Take care.
Alex, everybody have a good night.